Alright, so we're going to look at the review portion of the packet. We have Pythagorean theorem, 45, 45, 90, 30, 60, 90 triangles that we, in our trig ratios that we have to think about and deal with. So for the first one, I have two sides of a right triangle, which means it's a Pythagorean theorem problem if I'm looking for the third. And it's not a special triangle, so I just set it up. The hard part is remembering that C, right, is the hypotenuse, so that goes by itself. So x squared equals 8 squared plus 15 squared, and you work through the math and you solve it. For the next ones, these are my special triangles, so 30, 60, 90, 45, 45, 90. For the first one, I'm given the side opposite 30, which is great, because then I just double it for the hypotenuse, and it's the short side, root 3, for the side opposite 60, and so I get 18 and 9 root 3. My next one is isosceles, which means it's 45, 45, 90, so my other side is 12. And then x, the hypotenuse, becomes the legs root 2, so just 12 root 2. Now the last one is the trickiest one. I have a 30, 60, 90, but I'm looking for 30. I'm looking for the side opposite 30, I don't know it. You can't just say that this doubles for the hypotenuse and that this becomes 20 root 3. You have to solve for it. So in general, it was going to be the short side over here gets doubled, and then the short side x root 3 for this. So 20 has to equal x root 3, and we solve for it by dividing by root 3. I rationalize by multiplying root 3 over root 3, and x becomes 20 root 3 over 3, and it doesn't simplify any further. And so that is my value for x. I double that for the hypotenuse for y. 2 times 20 root 3 is 40 root 3 over 3. Alright, these ones are sine, cosine, and tangent ratios. The hardest part is figuring out where you start. So I start at A and identify the opposite, the adjacent, and hypotenuse. And then I use SOHCAHTOA. So sine is opposite over hypotenuse, becomes root 3 over 2. Cosine is 6 over 12, which is a half. And tangent, opposite over adjacent, is root 3. And then same thing for the next one. Opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse, 2 root 19 over 20, or root 19 over 10. Cosine is 18 over 20, or 9/10, and tangent is opposite over adjacent, which is root 19 over 9. And then the last one, I have opposite, adjacent, hypotenuse, and I set up my ratios, 16 over 20. I have 12 over 20 for cosine, which reduces, and tangent is opposite over adjacent, which is 4/3. Alright, we get into some word problems. This is very similar to one of the conceptual problems that we had. Let's draw it a little bit bigger so we can see. I have a 7-degree angle of depression, and I have two horizontals, which means again that these are alternate interior because the lines are parallel, and then I can solve for this missing piece here, x. So tangent is going to allow me to figure out x over 2. Now once I have that, I can use that value to subtract it from the height of the taller hill, and that will leave me with the height of the smaller hill. Right, this one again, I want to draw a picture. I have a building, I have an angle of elevation, I'm 305 feet away from the building, that's 42 degrees, and that's h. Now the hard thing to remember is that h is not all the way to the ground, right? We have to add the instrument height, which is 5 feet in this example. And so I'm going to solve for h with tangent because it's opposite and adjacent, and so I can get a value for h, and then I'll need to add 5 feet to that to get the actual height of the building. Right. This one I have a kite, so I have a kite in the air and a string to the ground that's 45 yards, and I'm looking for h, and so I have a 58-degree angle of elevation from the ground, so I don't have to add anything to it, and straight down is going to be a 90-degree angle, so I can figure this out with sine, right? Opposite and hypotenuse. Sine 58 is h over 45. I multiply by 45, and I get my value for h.